Howdy there, Mr. Sutton here, bringing you the Pre-Cal Honors 5-8 Part 1 homework solutions on simple trigonometric equations. For this one, we want to figure out sine of theta equals negative 0.7, what angles make that true between 0 and 360. We start by looking at what quadrants we're in, since we already have the trig function isolated here. Since sine is negative, that means we are below the x-axis, so that's going to be quadrants 3 and 4. So let's go ahead and do inverse sine of negative 0.7, and then whatever our calculator gives us for this, let's turn that into angles in quadrants 3 and 4. Sine inverse, negative 0.7 on the calculator, gives us negative 44.4 degrees. So the reference angle on that is going to be 44.4. We're going to use that to get our other angles here now. So for quadrant 3, that's going to be 180 plus 44.4, which is going to be 224.4 degrees. And then for quadrant 4, we need to do 360 minus 44.4, which is, let me use the calculator for this. That comes out to 315.6 degrees. For this problem, I'm trying to solve this equation for all angles between 0 and 360, nearest tenth of a degree. I'm going to start by isolating my trig function, this tan of theta here. I can do that by subtracting this 4 and dividing by negative 2. So let me do that on the calculator. So we have 8.04 minus 4 is 4.04, and then divide that by negative 2. We end up with tan of theta equaling negative 2.02. It's good to note at this point that tangent has a negative value. That means the slope of our angle is going to be negative, which means if we have a negative slope, we have to be in quadrants 2 and 4. All right, so let's go ahead and take inverse tan of negative 2.02 to see what kind of angle we get back from our calculator. So plugging that in, we come up with about negative 63.7 if we round that off. And we don't quite have a reference angle yet, but we're going to get one out of this. So negative 63.7, you're just going down 63.7 from the x-axis. So that means your reference angle is actually going to be positive 63.7. And we're going to use that now to get our quadrant 2 and 4 angles. So for quadrant 2, we need to start at 180 degrees and go backwards 63.7, so subtract that from 180. I'm going to do that on the calculator just to be on the safe side, and that comes up with 116.3 degrees. Next, for quadrant 4, we pretty much have to do the same thing, but we have to start at 360 and go backwards 63.7 into quadrant 4. So 360 minus 63.7, and I'll do the calculator for that as well. And that is going to give us another answer of 296.3 degrees. So those are our two answers. For this problem, we want to solve this trig equation between 0 and 360 degrees. Let's start by isolating cosine. So add 1, divide by 3. Cosine is 1/3. Since cosine is positive, that means we're to the right of the y-axis, so we're going to be looking in quadrants 1 and 4 after we get our reference angle. Next, to find the angle, we need to do inverse cosine of 1/3. So doing second cosine of 1/3, calculator gives us 70.5 degrees. That is also our reference angle, actually. We get the reference angle right off the bat. So let's go ahead and find our quadrant 1 and 4 angles off of that. For quadrant 1, we actually already have a quadrant 1 angle, 70.5, so we'll take that one pretty much for free. And then for quadrant 4, we need to do 360 minus our reference angle, which is going to be, let's see here, 289.5 degrees. There we go. To solve this equation, we're going to start by isolating the sine function. So adding 3 and dividing by 4, we have sine of theta equals positive 3/4. Since this is a positive value for sine, that means y values are positive, so our angle must be above the x-axis in quadrants 1 and 2. All right, so let's go ahead and take inverse sine of 3/4 now. And doing that on the calculator in degrees mode, we end up with 48.6 degrees. That is a reference angle. It also happens to be the quadrant 1 angle that we were looking for in the beginning here. Now for quadrant 2, we're just going to do 180 minus this reference angle. And that's going to be, let's see, 131.4 degrees. To solve this trig equation, we're going to start by isolating the cosine function. So we just have to divide both sides by 50 to do that. And I notice that I have a negative cosine. That means that my x values are negative, so I'm going to be to the left of the y-axis in quadrants 2 and 3. Let's go ahead and take cosine inverse now of negative 21/50 on the calculator. So if we do that in degrees, we get 114.8 degrees. We need to get a reference angle out of this, so we need to do 180 minus 114.8. And that's going to be, let's see here, 65.2 degrees. There we go. All right, now we need to find angles in quadrants 2 and 3. Now we already have the quadrant 2 angle. It's this 114.8 degrees that the calculator gave us. For quadrant 3, though, we need to use our reference angle. So that's going to be 180 plus 65.2, which is going to be, let's see here, 245.2 degrees. On this problem, we're trying to solve this trig equation in tenths of degrees. So we'll start by isolating the trig function. We can do that by adding 3 to both sides. So that's going to end up being, let's see here, 0.94 on the right side. And then if we go ahead and divide that by 2, 0.94 divided by 2 is going to be 0.47. So that's what sine has a value of. Now this is a positive value. So because sine is y values, that means that we must be above the x-axis, so in quadrants 1 and 2. So let's go ahead now and take the inverse sine of 0.47 and see what kind of angles we have. So inverse sine of 0.47, let's go to the calculator for that. Plugging this in the calculator, we come up with about 28.0 if we round that off. And then we need to figure out, so quadrant 1 and quadrant 2, and this is our initial angle here. So for quadrant 1, and by the way, this is a reference angle too because it's already between 0 and 90. For quadrant 1, we actually already have the angle. This 28.0 is in quadrant 1. To get the quadrant 2 angle, we just have to take this angle, which happens to be a reference angle, and figure out if we subtract that from 180, where are we in the second quadrant? So 180 minus that is going to give us, let's see here, 152. So 152 degrees will be our other angle, our quadrant 2 angle, and this is what it's going to take to solve this equation.